Chapter 6. Okay, this one is not that long. It just covers functions and what those are. So just a general idea. When we move on to our next classes, such as the Python and the Java course, we are going to go more in depth and we're going to learn how to actually write them. But today we're just going to focus on understanding what these are, why would we use them, and so on. Okay, so what is a function? So you have to think of a function as a mini program inside of your program. So a function is, the whole definition is a module that returns a value back to the part of the program that called it. But in simpler words, it's basically a little block of code that does something for you. So does some action for you. It can be small, it can be large. It just depends on what your program needs by itself. But just think of it as a block of code that performs a certain action for you as a programmer. Now, many languages will support the writing of your own functions, such as Python and Java, the ones that we're going to be focusing on. However, some of the older languages, they do not support the writing of your own functions. However, they will provide library functions. And what those are is pre-written functions that were already written by somebody else, by whoever created that coding language. And you can import those functions into your program and you can use them. There is a couple of examples, such as random number generator, and I will show you an example of that in Python when we get to it. But again, library functions, they also exist in Python in Java. And let's see if there's a couple of examples. For example, the random number generator. The random number generator will generate a random number for you. Well, it's not really a random number. It's a pre-written function that will statistically choose as random of a number as possible. But totally random number, it cannot give you a totally random number. There is a statistical let me show you how this looks. So for example, they're trying to use as many numbers, let's say 1 through 100. The statistical way of doing this, they will try to use 1, for example, like 5 times, then 2 will be used also 5 times, 3 5 times, and so on, so on, so on. So each number will be used around like 5 times, or the same amount of times. Each number will be used the same amount of times at the end. So if you run the number generator long enough, you will be able to predict, which number it's going to give you based on the pattern recognition. So there's no such thing as random in coding. However, we can try to get as close to random as we can. Now, where you would use those? Gaming, when you want to use when you want to create a tic-tac-toe generator, tic-tac-toe game, you will be using a random number generator to throw 1 for stone, or 2 for scissors, and 3 for paper. So this would be the idea of creating a tic-tac-toe game. Now, let's see. In encryption, also random number generator is very useful in encryption, in cybersecurity, to create ciphers and so on. And how this works, so usually you will call some sort of function, you will save it inside of your variable. So for example, in this case, we have a variable number, and we are trying to get a random number from a range of numbers from 1 to 100. So it will be something similar to this. But again, the syntax will be different. This is just pseudocode, but just so you understand, this will be something, the idea is like this. So you're going to call the function right here. This is the call of the function, random, and then you'll put from which range you want that number to be taken. Let's see. Now, there is 3 main things that you need to know whenever you're writing your own functions. Now, the first one is you will have to define a function header. Again, I will show you an example of that. Then you will have a function body. The function body is the actual code that's going to be executed when you call that function. And sometimes your function will have the return statement. However, there's 2 different there's two different ways to write functions. You can either use a return statement that will just mean that you are returning some sort of value back to your program. So if you are using the tic-tac-toe game example, if we're going to use that, you would create a function that would throw a random number, right? 1, 2, 3. And then you will return that number back to your program. So 1, 2, or 3 will be returned back to your program. But you can also create a block of code that will not be returning anything back to your program. For example, if you want to have a function that is matching passwords, right? Matching passwords of the user password that they entered and the user password that they have stored in a database. You can create a function that's going to match those two together and see if they are the same. If they're the same, it will not be returning anything. It will just let the user log in. So it's not going to print anything. It's not going to return any value. It's just going to let the user log into the website. But in this case, there would be no return statement. Okay, so let's look at this pseudocode right here. We have this little piece of code. So we have 3 integers that are declared: first age, second age, and total. And just a reminder, integer is any number that is not a decimal. So 1, 3, 10. If you don't see a decimal, that is an integer. Now, we are asking the user for their age and for their best friend's age. Now, we are displaying enter your age, then we're inputting that age and storing it in the first age variable. And then we're asking the user to enter their best friend's age. And again, we're storing that as a second age. In right here, you can see that we're user entered 22, user entered 24. So now in the first age, we store 22. And in the second age, we store 24. Then after that, we want to calculate the total sum of both ages. Now, again, you could have just written a general statement such as first age plus second age, but for the sake of this example, I'm going to show you how to actually write a function that's going to calculate that for you. Now, as you can see here, we are storing whatever is going to be calculated in a variable total. We are creating it. It's a new variable. We did not assign it to anything. So for now, we're just setting the total to a certain number that's going to be calculated using this function sum. Now let's look where that function is located. So to find that function, all that you need to do, you just need to find something that says function and the same name. So these two names need to be the same, sum, sum. As you can see here, that tells me that this is a declaration of the sum function. Now, to do that, now let's look at what is actually happening inside of this function. So this function, this is a header right here, line 21. Sorry, I drew all over it. Line 21 is actually the function header. Remember, we have a function header, function body, and the return statement. So line 21 right here is our function header. So what's going on here? We are defining a function. We are specifying that we have a return type of integer. So we're going to be returning something back, which is going to be an integer. Then this sum is just a name. You can choose whatever name you want. In this case, they chose sum. And these two inside of the parentheses, we're specifying that we want to send 2 integers into our function. So whatever we're sending into this function is going to be used for calculations. In this case, we're sending first age right here and second age. So technically, we're sending 22 and 24 right here.
Now, would you write first age? Sorry. Would you write first age where it has integer number 1 so it knows that's where it's getting the number from? Or
okay, so it doesn't matter because the only thing that matters is that these are the same right here. See that these two match. You can use whatever you want. However, in my personal experience, I would not name them the same way because just so it doesn't really confuse you. At this point, you can because the program is not that large, but when you will start working with more and more complex programs and you're going to code, like for example, this is only 25 lines. You will have programs that run for 400 lines, 500 lines, like huge programs, right? You do not really want to keep these the same, similar. Yeah, just so it doesn't confuse you or any other people that might be working on this program with you. Yeah. So these do
So
not
it
have
gets
to be
its
the
number,
same.
sorry. So it gets its numbers because of the sum word, right?
Yes, yes. So it just matches. So what's essentially gonna happen, it's gonna look at sum. Okay, we're gonna look at sum right here. And then it's gonna look integer num1. Well, we have an integer that's being sent. It is
Okay.
first age, but it is still an integer that's being sent. It doesn't matter what that integer is as long as an integer. So it sees first age is an integer, right? Because we declared it right here. First age is an integer. So we're gonna send that integer right here. And now that first age integer becomes num1 for this specific function, basically.
Gotcha.
All right. Then inside of that function, what we're doing, we're declaring the result integer right here. The result is just going to store whatever we calculate inside of that function. And what we are calculating essentially is just num1 plus num2, which is right here, num1, num2. So we're taking these two values, 22 and 24, we're combining them together. We're storing it in the result, which would be 46. 46 is then being sent back to the program because of the line 24. On line 24, you can see return result, and that is the return statement. So line 24 is the return statement. We are returning this number that we just calculated back to our program. So after these lines are executed, 46 will be returned right here. So instead of sum first age, second age, we will have 46. Again, it's not going to be visible to you. It's just what happens behind the screen, basically. So 46 is going to be returned, and 46 is going to be saved in this variable total. And let's look at the very end. What's happening right here? We're just ending our function. So even though, as you can see, this function is at the very end of your program, right? However, it's still, your program will jump. Once it sees that you're declaring a function, it's gonna go through every line of your code, look for that function. It will find that function eventually on line 21, even though there is a function, there is a display statement right here. It's just gonna skip it. It's going to skip the line 17, it's going to skip all of the comments, and then it's going to find the sum function, and it's going to perform whatever actions are inside of that sum functions, and then it's going to go all the way back to line 13. So even though we skipped all of these, we're still going to return to line 13 and then keep going as with the execution of our program. So the last thing that we're going to do, we're going to display together we're going to display our total, which was 46 years old. And you can see the program output here. This what would happen if you would run this pseudocode. Again, we can't really run pseudocode, but if you would code this in Python and you would run it in Python, this what would have happened. Enter your age, 22, enter your best friend's age, 24. Together, you're 46 years old. All right, let's see. Additional concerns. Okay. Whenever one of the main things that you need to know, you can only return one value. Most of the languages will let you return just one value, and that could be a variable or it could be an array. We're going to focus on arrays in a little bit. So an array is just a list of numbers. So it's going to be something like 1, 2, 3, so on, so on, so on, to whatever number you have as the last number in an array. And you can return this whole thing. That is also possible. You can return that. You can return many things. You can return a list. A list is something like, let's see, if you have strings, right? Name one, name 2. You can return a list like that also. Even though it's more than one value, right? It says you can only return one value, but your computer still considers, if it's one list, it considers it one value, even though the list has many different values inside of it. But for your computer, it's still considered just one value.
So if you wanted more return values, you would just put it in a list?
Yeah, you would put it either in an array or a list, just depending on what your program needs. But yeah, if you want to return more than one value, you can return an array, which will still be considered as one value, but you will have multiple values within that one value.
Okay.
Now let's see, why would we use functions? Kind of forgot to mention it. I'm explaining to you all of these ways to use them, but why do we need them? Right, simply, they're just going to simplify your code. So instead of writing like 400 lines of code, just one by one, you can write, for example, if you are checking passwords for somebody, you can either check them manually, right? For each person that logs in, you can just use get the input, check if it's the same. Then if it's the same, let the person go in. If it's not the same, let the person know that their password is not correct, and then do the same for user 2. So again, it would be like line 1, 2, 3 for one user, right? One user, and then you would do the same thing for user 2. But for example, it takes you, let's say, 15 lines to check somebody's password, right? 15 lines, 15 lines for the next person also to check their password. That would already be 30 lines. So instead of that, you can just write a function with those 15 lines, write a function and use that function for each one of the users. So instead of writing 45, 60 lines of code, you can just write 15 and reuse that for each one of the users that is logging in, instead of doing it manually. That's the main idea behind functions. Just reusage of your code. And again, if you have different programs, right, you will need to rewrite those functions eventually. But if you have a function that is doing something useful for you, for example, it's opening a file and inputting some lines from that file, for example, I don't know, it just, that's what came to my head. You're opening a file, you have a function that's going to open a file, read some lines, and return those lines back to your program. If you're doing it for one of your coding assignments or coding projects, you can grab that same function, as long as you're using the same language, programming language, you can grab that function, you can just copy and paste it into your new program, and you do not have to rewrite it. So once you know how to write a function, you don't really need to come up with it again. You can just copy and paste it into your new program, as long as you're using the same programming language.
A quick question.
Yeah.
Can you return a true and false
Yes,
statement?
absolutely. Since Boolean, remember, Boolean is a variable data type. It's the same as integer, it's the same as string, it's the same as float, which is a decimal. You can return a Boolean. And those functions are actually something that you're going to be using quite a lot. Those functions will specify that some sort of thing happened. For example, if the user logged in, right? If the user logged into your website, you can write a function that's going to be checking, did the user log in? If it's false, it's going to return false. So the user is not on the website. But however, the second the user logs in, that function will automatically check if the user is logged in and return true. And that way you will know that the user is on the website, because you just had true returned back to your main program. More library functions. Okay, mathematical functions, these are very popular. Most of these are already built in to your languages. This one is square root. These are pretty popular. Again, this is just pseudocode, but most of the languages, these have the same syntax. This means square root of 16, so just returns the square root of 16, which is 4. This one will raise the value of 4 to the power of 2, which is 16. So this is how you can use mathematical functions. Again, the same idea. You're going to put the name of that function, and then you're going to specify the arguments that needs to be specified. In the square root case, you only need one argument, the number of which you want to take the square root of, and if you want to take raise the value to a certain power, you have to specify which value you want to be raised, and to which power you want that value to be raised. All of these are very easily, you can find them in Google. So for example, you're working with a new language, right? You've never worked with it before. You don't know which library functions this language provides or which functions are built in. Just you can do a quick Google search. Google will be your best friend in whenever you get your first job as a programmer, because everybody uses it. Everybody, you know, it's impossible to remember everything, all of the knowledge that you need to know. So you have to know where to find your information and how to do it fast. So in this case, if you do not know which functions are provided by your language, all that you need to do is just Google the name of your language, library functions. That's it. It's going to show you either a table, a little table in images with all of the library functions, or it's going to tell you where you can find a website that will show you all of the library functions that that language provides to you. Here's some more mathematical functions such as cosine, sine, tan, tangent of an argument. So these are all, again, you know all of these from algebra. These are just the how to use them in
coding. Okay.
Yeah, in coding. So they are pretty much the same. The only difference is some languages will require you to import a certain package, such as import package math or something like that.
Okay.
And only after that you will be able to use them. And again, I'm going to show you the later on in later courses, Python and Java, I'm going to show you how to use all of them. You will know how to perform calculations like that in Python and Java. So there's a couple more, to integer and to real. Again, these library functions are provided almost in every single programming language. So real is usually, there's a couple of names to this. Real can also be called a float. You might see this, a float, or it can also be called decimal. It just depends on preference and what that language is called. So real, float, or decimal, they all mean the same thing. They all mean a number that has a decimal point after it. So 11.0, 11.3, these are all floats, decimals, or real points. Now, these two functions right here, to integer and to real, they do exactly what's in the name. To integer will convert whatever number you have into an integer. So you just have to be mindful of, for example, if you have 1.3 and you're using to integer, you will have 11, right? Because we're converting it to an integer. But at the same time, if you have 11.9, even though in our heads, if we're converting it to an integer, it should be 12, some languages will still convert it to 11.
Okay.
Because of
it doesn't round. Okay.
Yeah, because of the way it's converting. You just need to know how the conversion is done when you're working with those languages. But again, you will get it through trial and error, basically.
Okay.
Let's see. And to real is the opposite. So it's going to convert. An integer is going to convert it to a real. So for example, if you have 11, it's going to be 11.0. If you have 12 as an integer, it's going to convert it to 12.0. So to real will just add a 0.0 to your integer. That's all it's going to do. Formatting functions, there is a couple of languages that will provide these functions for you, not all of them. I don't think Python might have it. I know Java certainly does not have this function. However, what's going to happen is some of the languages have the currency format or other formatting functions, such as the date format. You know how they have it in Excel. In Excel, you can specify which format you want your number to be in. So some programming languages will also provide this. In this case, we have a real or a float value of 6,450.879. And if we formatted with the currency format in this example, this is the number that would be displayed for you. So a $sign, then a comma after the 6, and they're going to round up the 879 to 88. So this is the whole thing about the formatting. Again, just make sure that you know which languages do it, which languages do not do it, just in case if you want to use this in a language that does not support this function, you're just going to be very disappointed.
Yeah.
All right, string functions. You can work with strings. Again, strings, just to recap, string is just characters. So whatever characters you have, whatever characters you are working with, such as you can use words, sentences, text, doesn't really matter, just one character. It's all considered a string. And string functions, there's a couple of them, and these also the same as math functions. These will be available in most of the languages that you're going to be working with. Length will return how many characters you have in that string. However, it will also count spaces. So if you have, for example, dog space, let's consider this a space, cat, instead of just giving you lengths of 6, it's going to give you a length of 7 because of this space right here. So you have to be mindful of that. Append will join multiple strings together. And again, this is just an overview. You don't have to memorize all of these. You just have to know that they exist. If you forget what they do, you can just Google the name. Again, Google the name, look it up. You will remember it eventually. It's just don't beat yourself up if you forget what they're doing, or if you can't memorize them right away. Like, it's all good. Append will join two strings together. So for example, you have dog again and cat. If you put append dog and cat, let's say dog, cat, it will return to you something that looks like this. Notice how there is no space right here. So there will be no space unless you put a space either here or here. So again, you have to be mindful of that. Two upper and two lower are just two functions that will convert your string either to uppercase or lowercase. Again, so it's nothing too complicated. It's in the name. So two upper will put all of the characters as uppercase. Two lower will put all of the characters as lowercase. And substring is something that we will actually focus on in the Python class for a whole chapter. I think substring will extract a certain portion of your string. So for example, if we have a string dog cat right here, and we want to get a substring of just dog, we would have to specify substring, let's say substring from 0 to, let's see how many we have, 0, 1, 2, from 0 to 2 including. So this would give you just dog, just portion of dog. One thing to know when you're working with strings, you start counting from 0 instead of counting from 1. But that's a common occurrence in programming. So that's just something that you have to be remembering by default. We start counting at 0 instead of counting at 1. A couple more. Contains will just identify if there's a similar string within another string. So again, that example, dog cat, if you were looking, if that string contains dog, it will return true. So contains will only return either true or false. True if that string is a part of another string, false if it's not a part of that string. String to integer will convert a string to an integer. Again, pretty simple, pretty straightforward, as long as it's a number, as long as your string is a number. If your string is not a number, or if it has even a space or another character that is not a number, it will throw an error. So you have to be mindful of that. String to real, same idea, just we're converting it to a real instead of converting it to an integer. And these two, is integer and is real, kind of similar to the way contains work. It will either return true or false. And is integer checks if that string is an integer, and is real checks if that string is a real number. So again, everything is in the name. So I'm going to show you, we're going to finish off with showing you, I'm going to show you how these couple of things work in Python. So first of all, random numbers. Remember how I told you that sometimes we need to import certain packages? So this is the way to do it in Python. If you wanted to use the random number generator in Python, you would import random. The package name is random. You would put import random on the very top of your program. the very top, even before you start writing code. So before you start writing anything, you know you want to use a random number generator, you put import random at the very first line of your program. Then after that, this is how you would use this random package. So you would put the name of the package, random, then you would put a period, and then you would specify which function you want to use out of that package. So this is the way to do it in Python. You have to specify package name, put a period, and then specify which function you want to use from that package. In this case, we want to be returned a random integer. Therefore, we call rand int. And then we're specifying we want this random integer to be within the range of numbers from 1 to 100. So in this case, this will return a random number from 1 to 100 back to this variable number, and it's going to be stored in this variable number.
I could only assume they have other packages that go for the random, like.
Oh, absolutely. Let me see if there's. Okay, so there's no example here for that, but there's a whole piece of a chapter that's going to focus on just random numbers and random functions when we get to Python. I just like to show this to students beforehand, just so you see how it actually looks when you code it in a real language instead of just pseudocode.
Okay, gotcha.
So again, let's look at this how we can use this right here. Again, we are importing our random function. This definition main is just something that Python does. You don't really have to do it, but again, you're just defining your function that is a main. The main function is where all of your code is. This is just good programming, but you do not have to do this when you're just starting to work with Python. So they're just defining the function main. They're specifying that this is where our program begins right here. The first line is 4. They're specifying this is beginning of our main program. And we have a loop right here. 4 count in range 5, which means that this loop will run from 0 to 3 and 4. So it just specifies that this loop will run for 5 times total, starting at 0. 0, 1, 2, 3, 4. For 5 times, we're going to run this loop, and we're going to print a random number from 1 to 100, and then we're just going to print that number. So that's all that this loop is doing. And here's the example output. Again, if you try to run this in your Python compiler, you can just Google Python compiler online, and it's going to show you some website where you can actually try to code this. You can just copy and paste these words into that compiler. You will have completely different numbers, obviously, because it's a random number generator, but I would bet that you would not get a single one of these numbers if you try to run it on your end. But yeah, these are just random. 89, 7, 16, 41, 12. These are just printed because of this line right here. This will give us a random number from 1 to 100, and then we just print it. Let's see, writing a value returning function. Again, remember how we talked about returning a value back to the program? Now, this is our function header, definition, sum, num1, num2. This is our function header in Python. This is our body. This is the function body. And this is a return statement right here, return result. All that this function is doing is going to get 2 numbers, whatever is being sent, num1 and num2, whatever numbers are being sent, is going to add them together, and then it's going to return the result back to wherever this function was called. Here's an example of that same program that I showed you, but in Python. So instead of just being pseudocode, this is how to write it in Python. See how we have definition main and we have definition sum, but definition sum is inside of main already. So main is being called all the way at the end of the program. Again, this is not something that you have to do. This is just something that some programmers choose to do, because in Java requires you to define the beginning of your program. but Python does not really define. Python is very lenient with the syntax and the rules. So you can either do this or you can just get rid of these two lines completely. It's up to you and you alone. So this is it. Let me stop recording.